there, Wise families. Today we're going to be talking about adding fractions part 1. We're going to begin with the most simplistic scenario, which is when we have common denominators. That means the number on the bottom is indeed the same. We follow a few steps in solving problems like this. So here we go. We are going to first add the numerators, or the on top numbers. 2 plus 3 gives me 5. Now, our instincts tell us that we want to do exactly what we did on the top to the bottom, but your instincts would be wrong in this case. We are just going to be carrying the number 9 through, not adding it together. Wise families, today we are going to talk about adding fractions part 2. This is when things get just a little bit more complex. So today we're going to be talking about what happens when the denominators are not the same. So let's put some fractions together here. I'm going to make up some right now. Let's do 3/7 plus 1/2. As you can see, 2 and 7 are not equivalent. We have to create a common denominator making equivalent fractions, very much like we did in our comparing fractions video. So what I'm going to do is I'm going to make some equivalent fraction lines right down here. And I think to myself, how can I make 2 and 7 something common? Well, I can do that by multiplying them together. 2 times 7 gives me 14. So if I multiply the denominator by 2, I have to do the same thing to the top. And 3 times 2 will give me 6. Now, how did I get from 2 to 14? I multiplied by 7. Mr. Bouwman likes to call that crisscross multiplication, and what I do to the bottom, I must do to the top. And 1 times 7 is 7. Now I have a scenario where the denominator carries through, of course. Remember, we are not adding our denominator, and I can simply add the numerators. 6 plus 7 will give me 13. I know this is in simplest form because anytime I get an ending fraction where the numerator and denominator are only 1 apart, I know it's in simplest form. But just in case I don't want to believe that rule, I can list all of the factors for my numerator and denominator and prove that the only common divisor for them would be 1, meaning it is indeed in simplest form. Hi there, 5th grade families. Today we are going to be doing adding fractions part 3. And this time we're going to be making it even more complex. I know. This 5th grade math stuff is nothing to joke about. I have 5/6 plus 7/8. I have a very difficult problem here, and that is these denominators are not the same. Now, in the past, we've been multiplying them together to get a common denominator, and in this case, it would be 48. But I'm going to take this opportunity to show you how to find the least common denominator. So I'm going to move up here on my paper, and I am going to start skip counting 6 and 8 until I find something that they have in common. And here I go, 8, and now we have 16 and 24. Hold the phone. I see some equivalence, and it's right there. Now, what I'm going to do is I'm going to take that common number and make that my new denominator. So I ask myself, how many times did I skip count 6 in order to get 24? 1, 2, 3, and 4. That becomes my multiplier. And what I do on the bottom, I must do on top. So my new numerator is 5 times 4, which is 20. How many times did I skip count 8 to get to 24? Count it with me. 1 and a 2 and a 3. And what we do on the bottom, we must do on the top. 7 times 3 turns out to be 21. Now I have a beautiful scenario where that denominator can carry through, and all I have to do is add my numerators. Now I'm going to try to do this using mental math. So 21 is kind of like 20, and 20 plus 20 is 40, and then I can tack that 1 right back on at the end, giving me 41. Uh-oh, I have an improper fraction. That doesn't fly in 5th grade, friends. So we have to make this improper fraction a mixed number. The numerator becomes the dividend, or the number that goes in the house. 24 becomes the divisor, which kind of sounds like a scary bad guy who's knocking on the door of the house and wants to cut 41 into lots of pieces. And now what we do is we are going to say, how many times does 24 go into 41? Yes, it only goes in one time. We then multiply 1 times 24, giving us 24. We are going to find the difference, which will be our remainder. So since I can't take 4 from 1, I'm going to borrow from here, make that a 3, make this an 11, and 11 minus 4. Turns out it is 7, and 3 minus 2 is 1. So my remainder is 7. Now I like to go around the wheelhouse, as I like to call it, and pick numbers up. So the first number I pick up is 1. That's my whole number. The 17 is my numerator, and my denominator always stays the same. So the correct answer, the preferred answer, would be 1 and 17/24, which is now a proper fraction, mixed number, and it is indeed in simplest form because the largest divisor that the two of these could be divided by is 1.